Welcome everyone to another video about NPAS Unreal Engine plugin. In this video I'll be showcasing the controller system, which basically allows you to manage dependencies between interactable actors in your scene. So in other words, define how different actors relate to each other, for example, locking, unlocking interactions, enabling or disabling actors, basically triggering behavior based on the state of something else in the world, which then allows you to build structured gameplay logic. So interactions are not isolated, but instead react to what's happening around them. So let's add a controller to our scene. And let's call it IB controller, open it up. We can give it a name, although this is purely descriptive. So now instead of interactions, let's add a controller. So what we are going to do is that we would like to have the doorknob interactable actor only enabled when the player has the key. So let's start with manage interactables node, and we'll have two slots. For the first one, I'm going to find the door, and I'm going to say disabled, but including children, because doorknob is a child object for the door. And then let's actually set the key to enabled. So on begin play, key is enabled and door is disabled. And then we're going to go with inventory signal node, which is basically kind of a gateway, but it actually stops the execution based on the condition. So let's build a condition based on item. And I'm going to say the key. When it's successful, so when the player has the key, then we will actually go ahead and enable the door. So we don't need this one, and this door will now be enabled, of course, in my case, including children, because doorknob is a child actor of the door. Okay, let's see how it works. Save all. And you can already see that there is no outline around the doorknob, which means it's not interactable. I can't really do anything here, but let's take the key. Now I can open the door. Yes, okay, we have built our controller with a separate actor that we added to the scene, but you don't have to necessarily do this. You can also, of course, add controllers to interactables and combine them with interactions. So for example, let's go to the doorknob and let's add another output, and we're gonna add a controller. So basically kind of local controller to this interaction. And we are going also to use a signal on the same item, which basically means that the controller is waiting for the player to have a key. And then what we're going to do is we're going to use a manage interactions node, add a slot, and we're going to take that open interaction, and we are going to change the name to, for example, unlock. So now in our demo, we'll have two controllers at work. The one on the scene level, basically making this door enabled after the player gets the key, and the kind of local one on the doorknob, which is waiting for the same signal, changing the name, the display name of this interaction. So now we can open the door, and the display name has changed to unlock. Okay, so looking at the controller, you might have noticed that we're building a progressive pattern here, basically, with inventory signal. So one thing can only happen after the another thing happened. So in other words, one task can only be completed when another task is completed, which is very similar to a quest pattern. So let's actually use this combination and use our controller to turn the scene into a quest. So what we're going to do first is get rid of these two. And let's actually move it back, and let's actually give it a name. It's purely descriptive, it doesn't show up anywhere, but I think it's a good practice. What we're gonna do is we're gonna have our main controller request starting after the first time the player tries to open the door and it's not able to open the door. So let's wait for a signal on the event, on that event door locked. So when this event happens, we know that the quest should start. At this point, of course, we don't have it, so in order to use it, we need to register and then track that event. So let's go back to our doorknob, and let's go back to this path where the player is trying to open the door, and let's add that event in order for it to be tracked. So once we have it tracked, we can actually use it here, and this is where our quest starts. And the first thing I want to do is actually I want to communicate to the player that something starts here. So let's execute a blueprint, and I'm going to say quest started, find the key, and of course then after this happens, then we're gonna wait for a signal that the player has the key. That will move the quest forward, and then the second one will be, let's say, find the dagger, and then of course we're waiting for the player to pick up the dagger. Once this happens, let's say we complete our quest. So this is what we have. The controller will be waiting for the signal that the door is locked, and then we have these two, let's say, stages until the quest is completed. Actually, let's give the blueprint some lead time to communicate the name of the quest. So we have this one, find the key, and we have this one, find the dagger. Of course, we have to also implement that blueprint. So let's go back to our controller, and let's already go with switch on string, because we're gonna run two different sounds. So when this is quest completed, we're gonna play sound quest completed. Otherwise, we're gonna just run a quest task. And then what we want to do is just print out this task name on screen. And always, of course, we need to call back, because we need to notify now the interaction that our blueprint logic is over. So we have this, we have our quest, and yeah, let's try to complete the quest now. So as long as I'm not opening the door, nothing will happen. So let's try to open the door. So our quest started, we need to find the key. Let's find the dagger now.
Blood. It looks like he's hurt.
Okay, so the quest is completed, and with that our demo is completed. Thank you very much, and I'll see you in the next one.